Hey, folks, what's up? I hope you are all doing great. And it's another day when Azure developer community comes up with another session on a very interesting topic, that is Azure Custom Services. And today we have with us our speaker, Ms. Sanya Sinha, who is a Gold Microsoft Learn Student Ambassador, a community leader at VOC. She's also the regional Azure developer lead and also Azure hero and many other achievements in her portfolio. So she'd be one of the perfect persons to teach you for all the things related to the Azure Custom Vision services. So I'd request you all, and I hope it's going to be a wonderful session. If you have any kind of queries and doubts, you can please put them in the comments and she'll definitely help you with. Over to you, ma'am.
Thank you so much, Varun, for that really stupendous introduction. So, hi everyone, I'm Sanya, and without any further delay, let us begin straight with our workshop. So, let me just start sharing my screen. So, can you just tell me if my screen is visible?
Yes, ma'am, it's clearly visible. We can go ahead.
All right. All right. Thank you so much. So, I'm going to be talking about custom vision, which is basically an image recognition and an image classification or an object detection service brought to you by Microsoft Azure. So, this is a brief introduction about me. I'm a Gold Microsoft Learn Student Ambassador, Regional Azure Developer Lead, an Azure Hero, an AI Ambassador, as well as an upcoming AI researcher at the University of Texas in Austin. I'm very passionate about AI/ML and especially in the fields how Azure can actually revolutionize artificial intelligence and machine learning for developers. So let's talk about image recognition first. So, image recognition is an AI based solution revolutionizing modern technology. It deals with recognizing anomalies and deviations in images to interpret the quality and the usability of images. So, to sum it up in easy and more, viable words, I would say that whenever you look at a dog, you are able to identify that all right, this animal is actually a dog because you've actually seen the images of dogs before, right? However, if you ask a machine, so a machine cannot actually visually perceive things the way humans perceive things, right? However, using an image recognition service, your machines can visually perceive things just the way humans can perceive the same things. For example, if a machine has been trained to look at the images of dogs and recognize them, it would actually be able to recognize dogs on the basis of their external features. So, on the basis of this, we can actually say that image recognition is a branch of artificial intelligence that actually seeks to make your computers more visually intelligent in order to recognize images, classify them, and actually use them in production so as to make our lives simpler. So let's take a look at the various domains where we could actually use image recognition and where image recognition is being used thoroughly, exhaustively, and how can we actually use it to make our lives simpler. So let's talk about defect detection. So in the manufacturing domain, you can actually see that a lot of products go into production every single day. And out of these products, let's just say that even if 1% of those products were rendered defective or dysfunctional, it would ultimately come up to negatively impact the reputation of your organization, right? Therefore, not just for the sake of preserving your reputation, but also if you're talking about a small component, for example, a transistor. So, if you're producing a transistor, which is actually going to be used in multiple devices, small or large, and if the transistors that your firm or your organization is actually producing, actually ends up being dysfunctional or defective, then it would actually jeopardize the entire machine that it is going to be used in. Therefore, detecting these defects is the need of the hour. Using image recognition services, what you can actually do is that you can train an image recognition model with the images of typical transistors. So every time your machine learning model looks at those transistors, it would be able to detect any deviations in the typical transistors, and then it would be able to sidelight those transistors which actually have some deviations from the typical transistors and trigger an IoT based alert system or something, so that you know that okay, this transistor is dysfunctional, I need to either throw it away or I need to repair it again. So this is how you can use artificial intelligence image recognition, particularly in defect detection. Next up, we have image recognition in medicine. So in medicine, obviously, automated diagnosis was actually introduced because of image recognition. So every time your computer actually looks at tissues or it looks at vascular segmentation, it is able to detect anomalies and outliers in the anatomy of the particular component, in the anatomy of the organ that you're talking about. And with respect to that, it is able to detect that okay, this person is suffering from a disease or not, particularly if that disease has a tendency of visually manifesting itself in your organs. For example, if you're talking about brain tumor, so brain tumor is something that is actually very visually perceptive and can actually manifest changes in the brain. Moreover, diseases like breast tumor or diseases like melanoma or malaria, they can actually be detected visually because of the changes that they render in the human body, or the visual changes that they render in the human body that could be captured by proper imaging. Right. Therefore, AI in medicine has actually, image recognition in medicine has actually revolutionized the automated diagnosis landscape. And you don't even really need a doctor or a specialist to actually look into those images. You can straight away feed them into an automated diagnosis application, and then it would be able to detect whatever disease is it that you're suffering with. A very good example for this could be glaucoma. So glaucoma is basically caused if, for example, the optic cup to disc ratio is disfigured. So every time your doctor looks at it, it can actually be very tedious for even a doctor or even an expert to actually go through it time by time. So what he can do is that he can create an automated diagnosis platform, and then he could actually feed that okay, this is the optic cup, this is the optic disc, I have to take the ratio. If the ratio exceeds so this number, then this means this person is suffering from glaucoma. If not, then this person is safe. So, using automated diagnosis or using image recognition, you can actually detect diseases like glaucoma, diabetic retinopathy, brain tumor, breast tumor, melanoma, and so on very easily without the actual need of a specialist. Next, we have agriculture. So, if we're talking about the agricultural domain, if you have an image recognition model that has been trained on actually visually perceiving grown plants, it can then tell you that, okay, this plant has now fully grown. Now you can harvest this plant. Moreover, if we're talking about agriculture in image recognition, particularly in agriculture, it can even be used to detect spot diseases and parasites that infest your plants. So this is how you can actually use your image recognition services in agriculture in order to detect appropriate times for harvest, to detect appropriate times for irrigation, as well as any traces of diseases or any unhealthiness that would have crept into your plant. Next up, we have image recognition in retail. So, in the retail point of view, I guess one of the best examples for this could be self checkout counters. So, every time you go through a self checkout counter using with your basket or with your trolley, it can actually identify the individual objects separately, and then based on the data that has been fed into it, it can actually be able to recognize those different objects, and then it will be able to bill up the entire bill for your purchase, and it will be able to detect taxes and so on. So this is how image recognition in your day-to-day life is actually making your work so much simpler than it already was. So I hope this much was clear. If you have any doubts, feel free to put them up in the chat section. Now we're going to be talking about the custom vision service. So what exactly is Microsoft Azure's custom vision service? So Azure Custom Vision is a low code no code interface, is a low code no code image recognition service. So it lets you build, deploy, and improve your image identifier as well as image identification models. So it is an image classification and an object detection service that can help you classify images into multiple categories as well as identify particular objects in an image. For example, as I gave you the example of a dog and a cat. So, if you have trained your custom vision model to actually recognize images of dogs and recognize images of cats, it would be able to do that. However, let's just say if you have a particular image that actually entails a man who is throwing a frisbee to a dog in a park. So, in that image, you have multiple elements and multiple labels that would be associated with that image. For example, you would have a man, you would have a dog, you would have a frisbee, you would have various elements present in the park. For example, your swings, your benches, the trees, and so on, and all those components that actually make your park a park. So using custom vision, you cannot just only identify different images, or you cannot just only separate and classify images. You can also separate the different objects present in an image. And therefore, this is how object detection was actually amalgamated into your custom vision service. So you don't just classify your images into various categories, or for example, like you have binary classification, either a yes or a no, but you also have the capability of classifying the different objects present in an image. So this is actually a really great advantage that Azure's custom vision service has. So next up, your user can ultimately label the training images using personal discretion, because let's just say that I am the user and I am going to use my personal discretion to name your dogs and your cats that are going to be fed into my custom vision model. And after I have fed those, after I have labeled the images of dogs and cats, the classifier that has been inbuilt into custom vision service, it extracts features from the training images, and then it uses these features to classify the test images and the objects into various categories. So mostly it uses something like a convolutional neural network to actually identify these images and segregate them into various categories. The accuracy and the performance of the model is calculated on the basis of its performance on the training images itself. So if you take a look at the custom vision dashboard that I would be dealing with very soon in this video, so you would actually see that there are three main performance metrics that are used in the custom vision service. So these are precision, recall, and AP. And you would actually see that all these metrics are actually calculated on the training images first and for all. Later on, the test image results are eventually amalgamated, but for the first iteration, it's usually just for the training images only. Now, once you have trained your algorithm, you've actually published it, you have a prediction API, you have your endpoints created, you can test, you can retrain, and you can eventually use your custom vision model in your image recognition application for classifying images and your objects into different categories. So it's not really necessary for you to use an application using Flask. You can also use other Microsoft services, for example, Power Apps. You can very easily integrate Azure's custom vision service with Power Apps and create Power applications without writing a single line of code. So those are really great examples of using the custom vision service. And I really hope that you would love to explore this domain further and actually see what wonders can you do with Azure's custom vision. So, why should I use custom vision? Why should I simply not write 200 lines of code and use the custom vision service itself that does not require any code? Well, first and for all, you can create image classification and object detection models at scale. You don't need any other infrastructure or any GPUs or TPUs for the purpose. You can simply create image classification and OD models at scale with full scalability, full flexibility, and you don't need to worry about losing your compute or intensive storage resources. It's all on your Azure cloud. And if you already have a subscription, you don't even have to worry about the payment. So it can manage your resource, your custom vision resource, in a pay as you go model. This means that you only pay for the resources that you use. Now, if you have an Azure for Students account or an Azure free trial subscription, you are not going to pay for anything. This is just for an example wherein you have actually purchased an Azure subscription. Mostly the people automatically end up with an Azure free trial subscription or the Azure for Students version. And I would definitely suggest you to go for these versions. Once you are done with it, I think you will be pretty familiar with using Azure's custom vision. So I think one of the best advantages of Azure's custom vision is the UI. So you will take a look at it right now. And if you are familiar with machine learning and deep learning, you would know that creating image classification models is not as simple as custom vision is. It is an extremely simple UI. It is a drag and drop interface. It entails a dashboard with full support, full visibility. And you just have to drag your images, drop them into the UI. It actually processes everything on your own. You don't have to specify you don't have to tune any hyperparameters. Nothing is required. It is a no code interface, extremely simple to use. Even if you have no experience with machine learning or deep learning, you are free to use the custom vision service. This is what makes it so amazing and so good for beginners. Next, we have the facility of customizing your modeling experience. So usually other services that I entailed in Azure, like computer vision, they have already been trained on datasets like ImageNet and SSD MobileNet and so on. However, once you're using custom vision, You have full flexibility to add the images of your choice. You have complete control over the training images, and whatever the data that you are feeding into your system, either for training or for testing, is completely up to you. You are responsible for training. The metrics that are generated is because of the data that you have fed into it. It is completely under your command, and you have full authority over the modeling. So this is what makes custom vision so easy, and it's really very important for, I guess, everyone in the world to have experience, to have had experienced custom vision at least once, because of the amazing features that it offers. So, now in this particular workshop, we are going to be dealing with a very simple, beginner friendly, yet an amazing project of using Azure's custom vision service for malarial cell identification. So, malaria is actually a very common disease, and it's actually transmitted from the bites of mosquitoes, the bites of the female Anopheles mosquito, and it's basically due to a particular parasite called the Plasmodium. So, malaria, as you all know, usually manifests in third world countries, particularly around torrid zone, and it's actually known to have claimed over 400,000 lives annually, and it also affects about 290,000 people annually. So that's actually a really huge number. Naturally, diagnosing malaria is of the need of the hour right now. So if you're not familiar with how malaria is actually diagnosed, the basic step for it is to actually is actually to procure a drop of a prospective patient's blood and put it on a microscopic slide and then stain it. And so once you view it under a microscope, you could actually make out the presence of plasmodium which has been strained, and that is how malaria is actually detected. So in this particular workshop, we are going to be using a data set, which is this data set, and that data set basically contains blood smear images. Like I said, a blood drop on the slide, it contains blood smear images, and they have been categorized into parasitized and uninfected images. And then you can actually be able to use your custom vision service to classify your test images as either uninfected or malaria parasitized. All right, so let's just take a look at the data set once. So this is the dataset that I am going to be using. So if you take a look at the dataset, you can actually see that it has a total of 27,558 cell images with equal instances of parasitized and uninfected cells. So this means that there are approximately 13,000 or so parasitized images as well as 13,000 or so uninfected images. So over here, if you just scroll down, you would see an option for downloading the zip file, and once you download the zip file, it would look something like this. So inside my downloads folder, I have stored this cell images folder, which actually contains two files, parasitized and uninfected. Now this is actually something that I have done locally on my system in order to ease the understanding process. So what I've done is that inside my parasitized folder, I've actually created two other folders called test parasitized and train parasitized. So each of the train parasitized actually contains 10,000 images that I am going to be using for training, and test parasitized contains 3,000 images that I'm going to be using for testing. So while working with custom vision, I did not feed all the 10,000 images. I have used some 200 images or so only, just to give you a brief idea of how it's done, because otherwise the computational time would get exceeded by a lot and we don't have that much time. So I've done the same thing for uninfected as well. I've created two folders locally. One is for the testing and other is for the trading. The trading folder contains 10,000 images and the test folder contains 3,000 and 3,000 or so images. So I hope all of you are able to perceive this. Now let's get back to our data set. This is how you can download the dataset. If you have any confusions regarding the dataset, it has been taken from the National Library of Medicine, Lister Hill National Center for Biomedical Communications, and you can download it straight away from here. Now let's get back to our presentation. So I would actually link this in the description box in a little while. So now, whenever you're working with an Azure service, it's actually really important for you to create a resource. So in order to create a resource, I've actually created a very small video that is actually going to tell you how can you create your resources on the Azure portal. The Azure portal is like your one-stop destination for all Azure resources that you would like to create. So it's actually really simple to use an Azure portal, and just 1 second, let me actually show it to you. So this is what your Azure portal looks like. And I'm now going to show you what your how can you actually create a custom vision resource on your Azure portal. So let's get back to the slides. Yeah. So let's take a look at this video, and you would learn how to create a new resource. So if you can see this video right now, you can see that I've gone onto the custom vision service. I'm going to create a new custom vision resources by clicking on create over here. Now, next in the create options, you either have an option for creating a training resource or a prediction resource or both. So I have selected both in this. Just 1 minute. I'll have to fast forward it a little bit. Yeah, I've selected both over here. Now in the subscription details, I have actually selected Visual Studio Enterprise, which was actually the name of the subscription that I use for Microsoft Azure. Now it asks the resource group. Now, if you have never created a resource group before, I would advise you to click on create new and create a new resource group by typing in the name here. If you have already created a resource group, you have full authority to actually click on this drop down menu and choose the resource group that you would like to create. So once you click on create new, you can actually put in the name of the resource group that you want to create. So I think it was Malaria Demo 101 in my case. Yeah. So once you scroll down, now it's actually very important for you to create your instance. So within a resource, you can create multiple instances, however, only one instance for a single service. And now within the instance, you can actually specify where do you want your instance to be created. Now, since I am currently in India, I would definitely want my data, my instance to be created somewhere that is the closest to me. So if I create an instance in East US or in Japan East, then naturally it would take a lot of time for the processing. So therefore, it is always advisable to create an instance in the data center that is the closest to you, which in my case is Central India. You can use whichever data center is closest to you. So let's just select Central India over here, and you can choose any instance name as per your wishes. So I guess I have chosen something like Malaria Demo Detect 101, I think. Yeah. Now it's time for you to select your training resource. So you can either select a free tier for a training resource or a standard tier. So since I'm using an Azure subscription, and I have my credits left, I am going to be using the standard subscription. Just 1 second, let me back it up a little bit. I'm going to be using the standard tier both for training and prediction. So often it so happens that if you have selected a free tier for your training and you've selected a paid tier for prediction, it actually never makes to the scaffolds of validation. This means it fails at validation because it triggers a certain inconsistency that is actually very difficult to maintain when you're working with custom vision. So therefore, I would always advise you to select the same pricing tier for training as well as prediction, which in my case is standard. You can even use the free version, but obviously standard works better. And if you have your resources and your credits left, then all well and good. So click on review and create. Now it's running your validation, and it would actually validate and check whether all your basics are clear and whether the basic information that you have fed is clear or not. So it has finally passed validation. And once it has passed validation, you can click on create so as to create your new resource. So click on create over here, and it would actually initialize your deployment. So the deployment is in progress. I'm just going to skip this part and move it a little forward. So you can see that two resources have been created here. One is for the training resource and the other is your prediction resource. So it would take a little time to actually deploy. So I'm just going to fast forward it. And once the deployment has been done, it would say your deployment is complete. You can go to your resource group and you can check it out. Click on go to resource group. You could actually see the different services that are present over here. You can see Malaria Demo Detect 101, that is your training resource. You can see Malaria Demo Detect 101 prediction, that is your prediction resource. Both of these are custom vision resources. Both of these are located in Central India. So you can see this is how you can create your resource on on your Azure portal. So once you this is something that you would do every time you create a new resource. And no matter what service you're using, whether you're using Azure's cognitive services, whether you're using Azure's data services, whether you're using custom vision, no matter what service you're using, this step remains common, the one of creating a new resource. It's just that in the beginning, when you chose the resource group, which in my case was custom vision, you would have chosen something else like cognitive services, computer vision, virtual machines, app service, and so on. All right. So I think that this much was clear and you now know how to create a new resource. So let's just see how we can actually start with using custom vision. So How to create a new custom vision project. So first you need to create an Azure account if you don't already have one. So this is the link for getting an Azure for Student subscription. So you can just click over here if you like, and you can click over here to start your subscription for free. It would start with $100 of worth of Azure credit with no credit card required and all free services. So it's actually a really good start for you to actually start working with Microsoft Azure. Now, once you have created your Azure account, it would automatically transfer the $100 credit to your email ID. Now, we need you to use that same ID to log into Custom Vision projects. So, once you've actually created your Azure ID, go to this website, that is customvision.ai/projects. You can straight away go to customvision.ai and navigate projects over here there. But I figured out that this is the easiest method to do so. So, let's just click over here and you will be directed to the project's website. So it's loading my projects. If you have not created any projects before, this place would remain empty with just this particular button for new project. So since I was a little short on time, I have already created this malaria cell detection project over here, but I'll actually walk you through the entire process of creating a new project so that you don't have to worry. So click on new project over here. You can actually enter whatever details you like, and right over here I actually have a screenshot of all the details that I had entered. So the name for this was malaria cell detection. In the description it was detect malaria in cell images. The resource was malaria demo detect 101. It was an s not resource. um like I said, it was a standard resource. The project type is classification because this is an example of binary classification, and we are actually going to classify images on the basis of whether or not are they malaria positive or negative, right? So this is just an image classification example. Next we have classification type, whether is this a multi-label classification type or a multi-class classification type. So since I am only associating one label with each image, I am going to be opting for multi-class, which means a single tag is associated per image. The domain that I am going to be selecting is A2. You can even select A1 because neither of these aforementioned domains actually seem to correspond with the purpose of this project. Therefore, I have simply opted for general A2. Fine. So now that you have done this, you would be able to fill in. You would have to click on create projects once it's done. So once it's done, you would be led to a page that looks somewhat like this. All right. So I have already added a few images over here, but don't worry, I am going to walk you through the entire process of actually adding images in Custom Vision and then training your model. So what you are going to do in order to add images is that you can click on add images over here. So this is my testing folder, right? So I should go back to training. So these are some uninfected images. So every time you want to add an image, let's just go down. I'm selecting this particular image. Now that you have selected this image, you have to associate a particular tag with it. Now, I know already that this is a malaria negative image because it does not have the presence of the plasmodium parasite. And I know it because it was so classified in the data set that was provided to me, right? So over here, I have used two tags. One of them is positive, that stands for malaria positive, and the other one is negative, that stands for malaria negative. So since this is a malaria negative type of image, I am going to be classifying it as negative. Once I select negative, your custom vision service already knows that, all right, this is a malaria negative service. And once you have actually labeled this image with malaria negative, you can simply click on upload one file and your image has been uploaded. Now, this is how you add images in your custom vision service. You can even add multiple images simultaneously. So click on add images over here. You can just scroll down. Um, let's just say over here. Click on the first image, hold down shift key, click on the last image, click on open. It says 22 images will be added. Since all of these are negative, I'm simply going to be using the negative tag, which means all of these are malaria negative. So once I have selected negative, I'm just going to click on upload 22 files, and then your service would actually upload all those files into your service and click on done. The same process can actually be repeated for malaria positive images. So now you can see I have 153 negative images and 194 positive images. Now, once you are done adding your images, you have to click on train. You have to click on train, and under most circumstances I almost always choose quick training because it's definitely quicker. But even if you opt for the quick training facility, it takes over 15 to 20 minutes on an average. Therefore, I am not going to be retraining my model again. I am just going to be showing you its performance on the iteration that I had trained previously before the beginning of this workshop, so that it actually saves some time and you can actually try it out on your own if you want to. So go over to performance to actually see the performance of your model. So my model finished training on 26th at 12:43 a.m. in the general domain. This is an iteration ID that is associated with every iteration that you publish. This is the classification type, which was, as I told you, a multi-class classification example, which in which a single tag is associated with a single image. And if you take a look at these metrics, these are simply awesome. This is not overfitting. This is actually the performance of my model. It is accurately able to predict each and every image that has been fed into it. um, Over here you can set the probability threshold. This means that if your probability threshold is set to 50%, then only would it be able to classify as a good model. Now precision, which is actually performance metric, that is true positive by true positive plus false positive. Next you have recall, and next you have AP. So if you take a look at your performance per tag, the precision for the positive tag was 100, recall was 100, AP was 100, image count was 160. The performance for the negative tags were 100 for each. There were 160 images for the positive tag. There were 130 images for the negative tag. And next up, if you actually want to take a look at the performance of your model, you can actually click on the predictions options that comes up right over here. So click on prediction. So over here, I already used these images. So if you actually want to test a new image, click on quick test that comes up right over here. Once you click on quick test, you can actually browse for your local files. And let's just go to uninfected and select an image from the test data set. You can select any image. Let's just say I select this one. And over here, it says that there's a 65.8% probability of this being a negative image, which is true because this actually is a negative image. It has not been infected with malaria. And consequently, you can see that our model is actually performing really well. Let's look for another example. Go to cell images, look for parasitized, look for test parasitized. Let's look for this image. So it says there's a 99.9% probability of this being a malaria positive image, which is actually true because I'd actually obtained it from the test positive, sorry, from the parasitized images. So you can see now how well your custom vision model is performing. You can look at the metrics. Oh, okay. So if you have a little confusion with the metrics, precision is actually your true positive by true positive plus false positive. Your recall is actually true positive plus true negative over true positive plus false negative plus true negative. And AP is just like your average precision. So these are the metrics that I was talking about. Somebody just asked. Um, all right. So I think this was all. This was just how you could use your custom vision service to predict malaria. If you have any confusions, feel free to ask them in the chat.
Guys, if you have any kind of queries, you can kindly put it in the comment section and our speaker will be more than happier to solve your queries. We'll be waiting for 2 minutes. If you have anything to ask, please put it in the live chat.
Okay, I think we have a question over here which says, can you suggest how we can embed this in Power Apps? Yeah, absolutely. So actually, you would have to go. Just 1 second. Let me share my screen again. Um, So you will have to open your Power Apps. You would have to have a subscription for this as well. So once you go into Power Apps, it would actually ask you for any custom connector that you would need to have. For example, if I go and click on Create over here, just 1 moment. create a blank application, create a blank canvas app. Let's just select it for phone and let's me just name it demo. So once you've actually created your custom vision service, for the first thing that you will have to do is you actually have to publish your endpoint, which I have not done in this example because it would actually exhaust my resources. So I'm just going to show you what an actual endpoint looks like. So this is an endpoint that I had published previously when I was working on one of my projects. So if you take a look at this, it would give you a project id, it would give you a key, it would give you an endpoint, it would give you a resource id, and you could get all these if you actually go over here and you can, if you publish your model, which I already published in this case, so it's not actually popping up over here. So this is how you can actually get your prediction id and so on. And once you start with power apps, you'll actually have to go, you can have to click on add data, you can have to look for connectors, and in your connectors, you would actually have to look for custom vision, which is available right over here. And then once you click on custom vision, it would ask you for your prediction ID, your project ID, and so on. And then you can actually connect your service with Power Apps. So I hope this was clear. If you have any more doubts, feel free to put them in the chat box. No problem, Yaragani. Are there any more doubts?
I think there are no more doubts. So can we please wrap up with the session?
Yeah, sure.
So, thank you guys for coming here and spending your time with us. I hope you must have learned something new and interesting from our speaker. And obviously, thanks a lot to Ms. Sanya Sinha for coming here and delivering such an awesome and hands on tutorial for all our audience. It's surely going to be an enriching and insightful session. Thank you very much, ma'am, for coming here. And
Thank you.
surely we'll love to see you again delivering on some new topics. So, guys, thank you everyone for coming here. You all can join our Discord channels. I am embedding the link in the live chat, and we are having quizzes and every support for you guys. If you have any other queries on the particular topic, you can connect with the mentor on LinkedIn as well, and she'll be more than happy to help you over your doubts at that platform as well. So, thank you. See you.
Thank
Take
you.
care. Bye bye.